So we'll be discussing the Numpy usage in Python, because if you observe the usage of this particular Numpy, it is always gives us the usage of some kind of mathematical implications and all those aspects. Now what we'll try to understand is just we have seen some kind of the data structures. Apart from that, so just you can refer the uses of arrays and as well as the two-dimensional arrays, like those kind of aspects are there. So let me introduce the aspects like this. Numpy usage. Okay, so basically friends, here the objectives. Okay, so just I'm going to refer. Let me share the screen. Okay, now if you see the usage of this numpy, friends, basically numpy is a package which is provided by our Python. So as if you refer the orientation of this numpy is a numerical Python. So according to that particular name, easily you can grasp that this is a numerical kind of the aspect where you can refer some constructs in Python. Basically, friends, here we are going to discuss about the concept of the arrays and their how to create this particular array, and thereafter we'll see some of the aspects. Okay, some of the operations related to this particular array. And finally, we try to load some data with the help of NumPy, and then we'll perform some kind of the computings. So this is the flow of our session. Okay. Now coming to the aspects related to the NumPy. So as mentioned earlier, in NumPy, our majority of the focus is on concept of the arrays. Now, if you are referencing from the earlier knowledge on Python, we are having some kind of the list. So basically, friends, these particular lists are designed to store some heterogeneous kind of the data. That means I can store the integer type, float type, or string kind of the data. Okay, so but NumPy, friends, NumPy is intended to bring performance and functionality improvement for numerical computing. So because as the name imply, you can easily observe that which is basically the aspects of the numerical computing. Okay, numerical computing. Now you may ask me this question. So what is the benefit? Because if I am talking about the list, I am having the various functionalities, like I can go for heterogeneous kind of the data. But whereas if I'm talking about this NumPy, I should restrict some kind of the computing with the numerical orientation. Let me give the benefits, friends. Okay, so that you can easily observe which are all the aspects you can get with the help of the NumPy. Okay, the very first benefit is efficiently store ND arrays. Okay, so the first one is the efficient storage of ND arrays. Here, friends, ND might be either one dimensional, two dimensional, okay, many things. Okay, so sometimes only one column we may be working, like 1, 2, 3, 4, like that. Sometimes there is a possibility of working with multiple columns, maybe employee number and as well as the experience. Okay, so 10, 15, 20, like that. There is a possibility of using two-dimensional arrays also. Generally, friends, in two-dimensional arrays, so the very first thing, suppose if I am making use of the array and I am referencing this kind of the array as 2, 3, for example. So generally the declaration would be like this. So that means 2, 3. total 6 elements would be there. The first one is always referring rows and second one is always referring columns. Okay, that means suppose I'm having row 1, row 2 and column 1, column 2, column 3. So likewise you can create some kind of the two-dimensional array. Okay, so this is how you can refer the two-dimensional array. Now very simple, you can refer 1 1, 1 2, 1 3, 2 1, 2 2, 2 3. So likewise one can easily access the details of the arrays. Let us see that. So the efficient storage of the n-dimensional array is possible with the Numpy provision. Okay, and moreover friends, memory, if I am talking, so the usage of the memory, we'll see some example also how list is distinct with the array so that we can realize. And the efficient usage of this particular RAM is also possible with the usage of the arrays. That means the fastest, okay, in the fastest way, we can easily get the appropriate arrays as the same kind of the data we are using now. No need to handle the different categories of the data. Okay, and coming to the second one, the most important aspect, as if you know, if you observe these particular arrays, they are not different categories of the data. They are of the same type. So obviously we are getting the benefit of so efficient processing of the data. Okay, and without any type check. Because in the beginning only we are having the type of the array, maybe integer, float or something like that. So it need not every time verify what is the type of that particular data. Okay, simply you can make use of the same type, as the analogy behind this particular array is the same kind of the data structure usage. Okay, and one more important thing, apart from the memory usage and as well as fastness, the this particular NumPy friends is a base package, because as we are dealing with the data engineering or data science, whichever the means, it is available as a base for the other packages, you know, for the other packages. Like, you know, suppose if I am saying like NumPy, and on top of this NumPy, in the next session we are going to talk about the pandas. And similarly, this particular NumPy is also providing the base for the matplotlib, which is a visualization kind of thing, matplotlib. And on top of that, we are having the cburn library, which is also some other version of this Python, where you can perform the concept of visualizations. And pandas, of course, friends, which is very, very handy, and it is having the benefits of using the NumPy. And this particular pandas, you know, most frequently used package in our data science and data engineering. If you refer these four libraries, NumPy, pandas, matplotlib and cburn, these four are the most frequently used packages in the landscape of data engineering or data science. Now, if you are referencing these pandas again, we know this numerical kind of computing is done with the NumPy in the form of the arrays. And similarly, if I am talking about the matplotlib and cburn, these two are the libraries which are clearly allowing us to perform some kind of the visualizations. Apart from that, we are having this pandas, friends. Pandas is allowing us to get some kind of the data frame. Okay, we can get the data frame orientation along with some kind of the series. Okay, both the aspects we'll see. Okay, because if I'm talking about the series and as well as the data frame orientation, they are more handy when compared with arrays. Some other aspects would be added to this data frame and series, and so that one can easily refer the orientation of okay these NumPy over the, if I'm using pandas, definitely the representation wise, usage wise, is more handy when compared with the NumPy. When we come across to the pandas discussion, definitely you can realize. And another important thing, friends, you would have heard about the term broadcast actually. So this particular broadcast is nothing but applicability of Okay, applicability of some operation across all the dimensions. Across all the dimensions. That means suppose I'm having a 2 by 3 matrix and if and another matrix is also there. So if I want to perform some addition, subtraction or multiplication kind of thing, the same operation is broadcasted, which is applicable to all the variables or all the items which are there in the array. This also we'll see with the example. And now one more important thing, friends, which is as we are claiming that our numpy is a numerical kind of thing, it provide okay some kind of implementations. It provide the implementations of many many functions, implementations of many functions in the simplest way across linear algebra and statistics, friends. You know, one of the important point, if I am talking about the linear algebra, so far we have seen some kind of the arrays, and this particular arrays sometimes you can name as a matrix also. In the typical school mathematics, we will be having that matrix kind of the representation, row and column, some tabular fashion, and those kind of the addition and representations. All these things comes under the category of the linear algebra. And of course, guys, the statistical orientation, which is a mean, some kind of the median, some standard deviation, variance. You know, friends, based on our requirement, if you want to have the info or description of the data, then you can go ahead with the usage of these kind of the conventions. So, uh, if you refer the representation of okay, so these kind of numpy, we started our discussion with what exactly a numpy is, a numerical Python, and thereafter the main object which is provided by Python in the library of NumPy is arrays, and we are going to compare with list and as well as the arrays, and we are going to talk about how these NumPy arrays are flexible in terms of space and memory utilization and time wise also compared with other data structures. And as a part of our discussion, we have seen how fast and what is the main reason behind fastness of this particular arrays and all. As a general property of this particular arrays, you need not, so Python need not worry about the type checking, because arrays are holding the homogeneous kind of the data. And especially, friends, the other advantage of this particular NumPy is, which is basically acts as a fundamental package or library for other libraries such as pandas, matplotlib, and as well as the cban. Pandas again, which is most commonly used so as to apply some kind of the description and as well as to get some kind of the information related to uh, the constructs. And here in pandas we are having data frames and series. And apart from that, whatever the implementation you have done, if you want to maintain one kind of the visual effects, some kind of the visual aspects, you can maintain the orientation with the matplotlib and as well as the cban. Those things also subsequently we are going to discuss. And of course, as a part of this arrays, we are having most commonly used operation, which is a broadcasting, which is nothing but applicability of some kind of the operation across the domains. Okay, so many dimensions would be there if I'm talking about the arrays. Okay, and one more point we have seen, which is very interesting, like which is giving, providing us the orientation of the linear algebra and as well as the statistics, like some kind of the operations revolving around the arrays, and as well as we are having some kind of the statistical orientations, mean, median, standard deviation, and variance. Now what we'll do is just let me share this Python notebook, friends, Jupyter notebook. So our general habit, okay, so as to uh, perform some kind of the activities. So first let us discuss how the list can be used from the earlier data structures discussion, and then how we are going to compare the time factor in case of the array, because our claim is which is providing efficient storage and memory wise also we can enjoy the benefits. These things let us have a look on with small snippet, code snippet, so that one can easily have the understanding of how do we enjoy the benefits of the arrays practically. Now let me take this one number, friends. One bigger number I want to take some seven zeros after this one. 3, 4, 5, 6, 7. Okay, just I am declaring this particular n value directly. And what I'm doing is, friends, here just I am creating one list. Okay, and this particular list is list we can create many ways now. You can directly give the numbers, or you can make use of the range. Here I am using this particular range, okay, this high number, and I want to generate this particular list in such a way that those many numbers I want to generate. Now what I'm doing here is, friend, just observe here for I in a range of, okay, just what I'm doing is n. Every time from that particular n I am picking up one value, and we are going to list out, okay, that value whatever we have taken initially, that I value, and we are keep on updating, friends. Okay, so what we are doing is list one of I, and we are multiplying the same number uh, with the corresponding, okay, whatever the number we are getting, we are multiplying that number, and we are storing back that number into some list. Okay, this is what exactly our implementation. Okay, one small code with a larger range of numbers. But if I want to get the timing, friends, remember, suppose if you want to execute any kind of the code, and if at all you want to measure the timing, there are some magical commands with us, double percentage time. Now just to run this particular script, automatically you will be getting this kind of the number, see, 2.54 seconds. So as to generate this particular list and to perform this kind of the operation, our list, okay, this particular computing took 2.54 seconds. Now apart from these kind of the conventions, I can make use of some other aspects also. Suppose if I'm mentioning the usage of this particular list, okay, so and I want to perform some kind of the summation or those kind of the operations, so I can do that. So basically the same list I'm using, so list 2, just what I'm doing here is list of same, friends, range of n we are taking, and thereafter I want to perform some kind of the summation. So list one summation. Initially what I'm doing is, initially I'm not having any value in the summation, just we are assigning the value 0. Okay, then what we are doing for this time, we are taking item in. Okay, all our data items are in list 1, so just we are performing some aspect list 1 summation. Okay, every time I want to add list 1 summation plus, okay, item. That means one item we are fetching from the list, and we are adding keep on adding to that particular list. First time however list sum is 0, so next time the item will be added, and from that point onwards we are keep on accumulating. This is nothing but 0 plus 1 plus 2 plus, like that, whichever the numbers we're having. But our interest here is we want to use the magic command. Let us see for this how much amount of the time is required. Okay, just it is performing, it has performed in 1.21 seconds. You can easily observe for the multiplication it took 2.54 seconds, but whereas if I want to perform some kind of the addition of the numbers which are there, I can easily refer 1.21 seconds were required. Now, if I'm referencing the arrays, here the point is what we're expecting here is how do I reduce my timing if I am making use of my array kind of the notation. So in that particular case, friends, let us see both multiplication operation and as well as the summation in the context of the arrays. For that, friends, if you remember, in the explanation we have seen, NumPy is a kind of the library actually. Okay, so that what we need to do is we have to make use of that particular library in the current workspace. So what I am doing is here, just to observe, just we are importing. Okay, we are connecting our Jupyter notebook with respect to the NumPy. And guys, after importing this thing, every time you have to use a NumPy dot summation and NumPy dot maximum, like that. There are certain functionalities we are going to use. So rather than using such a word, you can create one alias name, and this alias name is in general in the development of the projects and all in the corporate kind of thing. We generally prefer the prefix, the appropriate alias as NP. So obviously that particular NumPy can be represented as a shortest form as NP. If you see that NP, all the software engineers and developers are making use of the alias name NP so as to refer our NumPy. And thereafter, friends, so just this time we are creating one array, and we are having this NumPy. And what we are doing is we are having one more functionality called a range actually. Okay, so a range. So just to I am making use of this same n. Okay, whatever we have taken in the this large number. Okay, for the array also I am making use of same number. Now what I am doing is I want to apply some multiplication. Guys, one of the advantage you can see here, I need not even assign some value after performing some kind of the operation. So simply I can give array into array with the help of the broadcast. It is going to perform some kind of the multiplication on each and every array which is present in the corresponding thing. Okay, so now our intention here is we want to get the timing also. So for that particular purpose, just what we can do is the magical function we can make use. So just you run these things. Okay, 1 minute. So first what we are doing is just let me make use of this convention. Okay, before that, just I can mention these things, or else separately also you can give, friends. Sometimes it won't array. Okay, so yeah, if you see here, array 1 I have declared, and we should use the same kind of the convention. Now you can easily observe whatever the timing I am having, 49.9 milliseconds, friends. Okay, 1000 nanoseconds equal to 1 second kind of things. Now if I am talking about the list, it is around seconds. Okay, 2.54 second, friends. But in case of the array, you can see this is in milliseconds, which is very less. Okay, the time taken by this array so as to maintain this multiplication is very less. We'll discuss how the representation and all, because if I'm talking about the list, it is giving in one display kind of thing, and arrays. Okay, we have not yet seen the functionality, so that just to be mindful. Okay, so let us jump into that particular discussion in a while. Now you may claim that, okay, because it is a multiplication kind of thing you can observe, but what about the addition or something like that? So for that particular thing, friends, let us compute the timing for addition also. What we are taking is array 2. So just I am making use of np dot. Obviously, friends, one of the advantages is just you can type first 2 or 3 letters and you can use the tab. Python provides us a nice IntelliSense. And here also the same number, large number we are using. This time what I am using is array summation. So just I am applying some np dot summation of array 2, whatever the array I'm having. So simply I can make use of the existing functionality. I need not perform any user defined or explicit logics also. So simply you can perform some kind of the aspects where you can use the predefined functionalities, right? Okay, now you run this particular code. Obviously it is very less, friends, 22.9 milliseconds. So at least in case of the list, if you see, it is 1.21. but now it is 22.9 milliseconds, so that we can easily conclude from the practical implementation. Okay, so if you are referencing the kind of representation of the arrays, it is always took less time in case of addition or multiplication when compared with the list kind of the data structure. So that this is evidence basically. So like, you know, one can easily observe, suppose if the time is a constraint and if you want to make use of the time efficiently, then you can go and make use of these kind of the conventions. Okay, now friend, before starting of this arrays, just we are having the a range usage now. So what exactly this particular a range is? A range functionality, so basically what it does is it is returning some values. Okay, it returns an array. Okay, whatever the values we are taking, it is going to return an array with evenly spaced. You can easily observe. Okay, evenly spaced elements. Okay, just nicely arranged elements as per the given interval. As per the given interval. So interval, whatever the range of values you want to give. So based on that particular convention, one can easily observe the kind of the numbers generated by the array. Now let me see the array representation. This time we are taking up the array. So np dot a range of, as I mentioned, directly you can make use of two or three letters and you can give this time we are not going to handle those many numbers. Just for the sake of the demonstration, we have seen that number. Now what we are doing is a range of 5. So just I want to create this particular array, and now let us print this particular thing. Print, what I am doing is array. Along with this particular array, I want to print the type of array also. So the convention here is, friends, within the same print statement, I can able to display the array representation because it is starting from 0. A typical Python convention where your index start from 0 and ends at suppose if I am taking a comma b, a is included and b is not included, b minus 1, up to b minus 1 it is going to perform. So this is one kind of the representation, and moreover you can directly take this particular ARR, directly you can see that this is the array type of thing. Now, if you want to know the data type of this array, okay, simply you can see d type as integer 32. That means we are only using the integer kind of the data. Sometimes, friends, if I want to refer the arrays like this, maybe I can use um, np.array. This is also one more methodology where I can use the list kind of the data so as to declare the array. That is your wish, friend. Maybe you can use the arrange functionality, or else you can directly give the array representation. So with the help of those kind of the conventions, one can easily specify the declaration of the array. Okay, now just to observe here, very first element I have given as 0.0 and is replicating to all the numbers, the floating type. Reason behind this is as arrays are homogeneous kind of the data items. Okay, so whatever the number I am giving as a float, the same will be applicable or broadcasted to all the other kind of thing. So that is the floating type, and you can easily check the data type actually. So always you can check the data type, which is a floating point of the number. Okay, so this is how you can make use of the array specifications. Okay, so far we have seen only 1D arrays, but at times, you know, there is a possibility of making use of the two-dimensional arrays also. Okay, so for that particular thing, just we're having the two-dimensional array. Let me declare that array like this, array 2D, and this time also we are making use of the np.array. Now one small convention, friends, here. So because if I'm talking about the two-dimensional array, there are some combination of the rows and as well as the columns. Okay, so obviously I need to refer some set of the rows and as well as the columns. All those things again represented by this bracket. Now what you can do is just you can observe this simple representation, friends, while declaring the two-dimensional array. Okay, like how we are declaring in a typical mathematical orientation. So just I am taking this 4, 5, 6. Okay, that means here what we have done is just we are working with the uh, two-dimensional array in such a way that so just with the array this is function, okay, open bracket, and then as this is two-dimensional we are having some set of rows and as well as the column. Okay, can you see here what is the type of this array, friends? Yes, okay, that is a 2 by 3. That means two rows and as well as the three columns. Correct. So the 2 by 3 kind of the arrays you can declare like this. Okay, so just you can run this. Okay, and basically if you are saying this array 2, see how nicely it has represented. Okay, similarly, array 2D dot some kind of the dimensions, number of dimensions available, a two-dimensional matrix. Okay, 2D, because in the earlier examples we have only used the one-dimensional. Now, one more interesting aspect is there, friends. Suppose if you are having any doubt related to the array kind of thing, maybe you have seen some array long back in the declaration of your Jupyter notebook, but later point of time you want to know how many rows and how many columns were there. You can simply apply the shape of the shape of that. But if you want to get the shape, just you can give the array 2D dot shape. So just it is giving that how many rows and how many columns are there. And one more thing, friend, just you see here what exactly I'm doing. Just if I'm giving the size, see this particular size has emitted 6. That means the number of elements in that particular array, 1, 2, 3, 4, 5, 6, total number of the elements. Whereas shape is something like the appearance. So how the rows and columns are there, all those kind of the things you can easily specify. Now there are certain aspects, friends. Maybe you want to apply some kind of the functionality and you want to generate some kind of the arrays only zeros, or if I want to have my array only once. Okay, so there are certain aspects which are provided by NumPy. Okay, every time, friends, if you want to use the NumPy, just that alias name is there na, initially we have declared import NumPy as np. Okay, the same kind of thing alias we are using. Okay, so np dot, this time what I'm doing here, friend, just observe, I'm making use of this ones. Okay, ones of 3 by 4. Okay, let us see what it is giving. The error cannot interpret 4 as a data type. Now what you need to do is remember one important point, friends. Whenever you are using some multi-dimensional array, that means 2 by 3, 3 by 4, or whichever, Python expects, especially this NumPy expects two dimensions. Na? So again, we have to give this dimension and as well as this one. Okay, so automatically it recognizes, oh, this guy is instructing me to make use of the two dimensional. Now you see. Okay, obviously even I have not given any print statement or the kind of even we are not storing this arrays anywhere. So simply we have generated 3 rows and as well as the 4 columns with all ones. Okay, so similarly if you want to apply, suppose broadcasting I have we have seen. So just I want to see here what is the outcome. 100 into np dot ones of, just I am making use of the 3 by 4, the same above declaration. You can easily observe, friends, not only once, suppose all hundreds I want or all 50s I want. So just with the help of the broadcasting kind of thing, whatever the scalar, whatever the number I am using, the same number is going to replicate in all the numbers which are there in the arrays. So this is also one of the advantage where you can generate the zeros and applicability of this particular broadcasting, something like that. And thereafter, if you refer, guys, so this is one more functionality we are having, np dot zeros of same 2 by 3. That means here we are going to generate 2 rows and as well as the 3 columns, because in a typical array the first item represent the row, the second item represent the column. So that we are making use of that np dot zeros as 2 comma 3. So just observe here. Obviously you can refer the zeros with the 2 rows and as well as the 3 column representation. So this is these are all some of the aspects provided by our NumPy. Okay, and some more, maybe one more point coming into your mind. Okay, in the earlier examples, we have taken manual numbers and then we have generated with zeros and ones kind of thing. And is there any possibility of randomly generating the numbers, or is there any value? Is there any possibility of using these kind of the things with the random notation? Of course, friends, we are having that possibility also. So just have a look on this np dot. Okay, if you don't want to give the numbers manually, you want to generate the numbers randomly. Okay, so just observe here 2 by 3. Automatically it is going to generate random numbers with the specified rows and as well as the columns. Now you may be having some doubt. In the earlier declarations I have used for the multi-dimensional these double brackets. But remember friends, as we are generating the random numbers, and random numbers purely works on your instruction like 2 rows and 3 columns. So you need not explicitly mention the dimensions. Okay, so let us give this what happens even if you are following the same convention as the arrays, it is going to return the error. Okay, because we know that tuple is a representation of this thing. Obviously your random is misinterpreting that particular thing as a tuple. So here and there some of the aspects we need to observe, though we are not aware. Okay, just with the instructions given by the documentation of that particular Jupyter. Okay, one can easily observe the syntax. You know, here if I'm talking about the syntax, in the earlier sessions also we have seen, suppose if any functionality or if any syntax I was not aware. So just to you place your cursor into the function and just you can refer shift tab. Okay, obviously it is showing us a nice documentation. I strongly recommend you guys just you can make use of this documentation so that one can easily get what exactly the benefit and how do I use this and what is the syntax. All these kind of the conventions one can easily specify. So random value generation and along with some examples also there, friends. Okay, whatever the examples we are taking, apart from that, I suggest you guys you pick up with these kind of the examples also, which are very simple to interpret. Okay, so this is how you can observe the random generation. So I'm having some set of the values and all so that I can manage that. And similarly, friends, if I'm performing some, if I want to perform some kind of the operations, maybe I can say like this array1 np dot. Somewhere you have seen the zeros. Definitely I should provide 3 by 4. Okay, similarly what I'm doing is I'm taking one more array and np dot. This time once I'm going to take some 3 by 4. Okay, same dimensions. Okay, so I can simply say array1 array2 and I want to apply some kind of the operation. Simply array1, just I want to apply some arithmetic operations. Okay, simply both the arrays are going to add with the help of that broadcasting. Similarly, array1 minus array2, as you expected, all minus ones we are taking because array1 is purely containing 0. Our array2 is containing some minus numbers. Okay, and sometimes though it's not strict to ones or zeros, friends, maybe with the random numbers also one can easily observe. Okay, whatever the data items I'm having, one can easily specify mm, uh, with the random numbers also we can apply the operations. Okay, now let us have this thing np of square root of suppose if I am giving array1. Okay, and because zeros are there now, we are not seeing any differentiation. Whereas in the random, actually the random is available. We have not stored anywhere now. Let us take that example also. Array1 I am taking this time np dot random dot. Okay, random number 3 by 4. Some kind of the numbers generated by our NumPy randomly. The numbers were generated like 3 rows and as well as the 4 columns. Now you can perform whatever the activities, like this time np dot sqrt of array 1. So simply it is going to apply the whatever the function we have specified, and that is broadcasted to all those kind of the numbers. Okay, so likewise in this aspects you can simply declare the arrays with a range function, or else you can declare with zeros or ones, or else you can make use of the functionality guys with the help. 1 minute friends. Okay, so one more important thing, uh, if you are referencing the kind of the numpy, already we have seen in the explanation some statistical functions also we are having. What we are doing is just this time just we are making use of some convention, some minimum, maximum, or those kind of the aspects. Let us see. So stats with the numpy usage. Okay, so now over the aspects we're having this time also we are creating one array with the support of npy, our favorite random dot random of some numbers you can use friends. Okay, this time see 3 4 5, one bigger number I am using. Now if you see here, okay, likewise we are having some kind of the numbers generated, randomly number generated, and now I want to know what is the shape of this particular thing. These many numbers were generated, and from this particular thing if I want to perform some identification of the minimum value, there are certain functionalities friends, a min and as well as the a max, array minimum and array maximum, and you can supply the array, so automatically it is giving the minimum value, and np dot a max of, and now you can supply this particular array value which is giving the maximum value. Okay, so accordingly you can perform the minimum and as well as the maximum. And one more thing, we are having this mean value now. Suppose sometimes I may want to get the mean of the numbers, those values. You can easily see this what exactly mean, and variance value np dot variance, how the data is varying, how the number. Suppose I'm having some different numbers, and how one number is distinct with another number. What is the variance? Okay, so that you can see, and similarly we are having some kind of the standard deviation. Okay, these things may not directly useful friends, but in case of understanding of the data, in case of describing the data, you may be having these kind of the conventions. Okay, so this is how you can refer the mean, standard deviation, variance related to the statistical computing, and maybe you can deal the median value also, where it is giving the fair understanding of the data. So this is what how you can refer the concept of the arrays and how we are declaring the array and how to perform the kind of the array operations, like with finding out of the maximum, minimum, standard deviation, variance, all those kind of the conventions. Now let us have a look on this example friends. One case study I want to give to you. Be with me guys. Suppose I'm having one array with me, like what I'm having is np dot random dot. This time we are going to generate the integer values only. Earlier if you see all our random thing is a kind of floating values or something like that, but this time I want to perform only the integer based data, and what I'm taking is starting from the 50 up to 80. Like that I want to generate some kind of the numbers. Similarly I'm taking one more array. This time what I'm taking is np dot random dot random integer. Okay, starting value as 150, and up to 185 I want to maintain, and 100 such numbers as. And another thing is 1 minute guys. Okay, no problem. Array 3. So just you can manage np dot random dot. Okay, np dot random dot. 1 minute. So once you observe these kind of the things, okay, np dot random dot randint of another third array I'm taking. This time I'm taking 17, 22 and as well as such kind of the numbers. You may be wondering friends what this guy is doing. Okay, so a later point of time assume that we got these kind of the things from various sources. One is weight of the persons that particular array is representing, and second thing is representing height of the person, and the third thing is representing the age of the persons. Okay, age of the persons. Now at the moment you are talking about this kind of the notation friends, uh, so I'm having some numbers, weight, height and as well as the age, and I should verify these. Suppose like this, let me explain this. Suppose one person weight is 57 kgs and maybe 165 cm, and age is some 20, assume that. So that means there is a correlation, coordination and some correspondingness. 57 weight, the corresponding height is 165 and the corresponding age of the person is 20. So though we got these particular arrays in a different things, but I want to tag them correspondingly. So there is one nice, I can say there is one nice functionality is there friends, which is nothing but the v stack. Okay, see here, np dot v stack of. Now this is a multi-dimensional array na? Okay, so that what we are doing, array 1, array 2, array 3. Okay, so just what we are doing friends here, just we want to check this shape also. Can someone expect what is could be the shape? That means number of rows. How many number of rows we are having guys? 3. One is weight, another is height and age. Like that we are having 100 elements, 0 to 99. So shape must be like this, 3 by 100. Okay, now you let me take the shape of this particular thing. Okay, at the moment I am running this. Yes. Okay, that means 3 rows. Obviously first row is the weight, second is the height and third one is the age. Now in this case, okay, what I am doing is here, let me store this particular value in the array so that I can flexibly perform the operations. And this time array 1, array 2 and array 3. 1 minute guys. Okay, so now I could able to store this particular data into arrays, and now we stack, see stacks, okay, which is stacking the group of arrays, whatever the arrays I'm having in sequence vertically. So just it is maintaining the row wise, okay, because I need weight as one row and height as another row and age as another row. Like that I need to maintain all the numbers, all the corresponding numbers. So obviously this VStack helps us to stack those particular arrays. Now array 4, okay, I'm having. Now assume here friends, just I'm having the arrays. I'm having the random integer, but I'm strictly saying that my minimum weight is 50, height is 150 and age is 17. You can easily grasp this point. So as to check what is your minimum, okay, just be with me guys. Minimum of array 4. Okay, array 4 means it should give the minimum of see, just if I'm running this, what I'm getting friends, 17. That means age wise. But my intention here is just I'm little bit changing this particular analogy, like a minimum of final array. Be with me guys. Array equal to 1. I mean x is equal to 1. Let now you see what it is saying. Minimum weight 50, minimum height 150, 17. See, that means your axis. Okay, if I am not providing any access, it is giving only the latest, that means age is the latest array na? So it is pointing to that one, that column only. But whereas if I am providing this access equal to 1, it is running through all the values and it is going to pick up okay all the values minimum. Similarly, and as we expected, np dot a max of simple array for x is equal to 1, maximum values, whatever the maximum values we're having, all those maximum values we can get. Not only this guys, but mean also, np dot, sometimes you know what is the minimum age, what is the minimum I mean mean weight, mean salaries, mean height. So in that particular case also you can straight away use this particular kind of the convention. See how good it is. Okay, simply just with the help of one functionality, all the individual arrays provided friends here. We got this input data from various sources, but they recorded in a different from different time slices. Maybe the data is same. That means weight, height, and age. Definitely, there should be some corresponding thing is there. But at times, maybe this particular functionality is helpful. This VStack kind of thing, where you can you want to tag those particular values correspondingly. Okay, so straight away you can make use of this particular things. Now there are certain aspects friends. Okay, let us see this array 4. Now you see, hmm, what it is saying friends, I got the maximum actually, whatever the maximum value I'm having, I got minimum or maximum value where that value resides, which is what is the index value. So for that, if you want to get the location of that maximum value or the location of that minimum value, suppose if you see array 4 dot um, location, okay, whatever the array I'm having, that location I can easily get. Okay, so this is how you can refer the usage of the statistical functionalities along with these kind of the notations. So with this we'll do one thing friends, uh, all these kind of the things, you know, starting from this chapter of the numpy, we started our discussion by comparing the list and as well as the list with multiplication, list with addition, along with the arrays and as well as these kind of the summations and all. And we can able to see the time usage related to um, arrays and as well as the list. Okay, there we concluded that definitely arrays are required less time when compared with the list. And thereafter the numpy, you know, which is a famous library, and you can make use of this arrange and as well as array kind of the functionalities to generate your arrays. And thereafter we have seen the type of the array, and there then we have seen the two-dimensional array creation manually. And then there are certain predefined aspects which are available and which are provided by our numpy, like ones and zeros generation, and there is a broadcast kind of thing. Okay, and random, which is most commonly used kind of thing. If at all you want to generate some kind of the random numbers and you want to perform some kind of the activities, you can make use of this representation, right? Okay, and then continuing like performance of some arithmetic operations and some kind of the available functionalities on top of these values. Okay, right. And statistical computing, like, you know, after generation of some numbers, I want to perform, I want to get minimum, maximum, mean value, variance, standard deviation, median. At times there are certain possibility of making use of those kind of the conventions also. Now, there is a separate situation, friend, where you may be having some weight, height, and age, but you want to make use of those three arrays as a common object. Okay, so that you can easily perform like the computings and all. So for that, we're having very useful functionality, that is a V stack, where you can tag all these different kinds of the arrays, and you can observe as a recheck. You can see the shape, which is now saying 3 rows, okay, with weight, height, and age, and with 100 different values pertaining to weight, height, and as well as the age. And thereafter, as usual, friends, we have seen minimum value and as well as, but one more point we have observed here, axis. Suppose if I am not providing anything, just it is taking the column, a particular column or default column, and it is giving some value. Whereas if you are referencing the axis as 1, it is seeing across the all the rows, all the columns, friend, because we are having weight, height, and as well as the age. Out of those particular things, it is picking up what is the minimum, what is the maximum, what is the mean, and sometimes, you know, I want to get the maximum. I want to get the argument. I mean the index value. Okay, so which is returning the index or indice of the max value along with the given axis. Okay, so this is how you can refer. Now, one more important point you can perform with the numpy is loading of the data, friends. Okay, so here we are having some kind of the cricket data with us, and that particular data I have stored for you guys. Let me open that. Ah. So this particular cricket data I want to open. Uh, yes, see here what exactly the data is of our favorite player. Cricket means. So we are having some as usual serial number, and these particular things are the runs scored by Sachin and Rahul Dravid and as well as the Indian team, the entire team. So you can easily see that how many runs were scored by Sachin and how many runs were scored by the second, the third one. So here the serial number. After the serial number, we are having the runs scored by Sachin and runs scored by Dravid and runs scored by our entire team in that particular match. So likewise, we are having various kinds of the rows. Okay, how many rows we have recorded? We are having some oh, 224. Okay, 224 rows we are having. So now what we want to do is we want to, yeah, however it got from 0, obviously 225 rows and 4 columns we are having along with the serial number, runs scored by Sachin, runs scored by Rahul Dravid, runs scored by India. This is the context of our data. Now our intention is we want to load this particular data with the help of the NumPy, because once the data is available, then only we are going to perform some kind of the activities. Okay, first let us load that particular data, and we are going to store that particular data somewhere in our array. Okay, so let us have a look on this, friends. Uh, just let me record loading the data with NumPy. Okay, this is the concept. What I'm doing is here, friends, I'm making use of for understanding Greek data. I'm going to store this data. Now NP, which is the NumPy. This time we're having load text. So just now we have seen the kind of the data, you know, so this particular kind of the data is available in, if you see the extension, tab separated value. Okay, generally we see comma separated value, and those comma separated values I am going to introduce you in pandas, friends, actually in pandas. And most of the time, friends, our 99% of use cases, we are making use of the comma separated values. But I thought of showing you this tab separated value. However, CSV kind of thing we are going to talk with along with many uh, kind of I mean pandas and matplotlib and all those kind of things, so that we tab separated value. You can see the extension TSV. Now what we're doing is just after making use of this particular data, so just load text. Okay, so just you need to give only first 2 letters and give tab, friend. You need not remember the entire data. Okay, so just let us load this particular thing. Okay, obviously it has given some error, friends. What it is saying, could not convert string to float. could not convert string to float, because the reason is, friends, simple. If you, yeah, your expectation is correct, because you know the first thing, it is observing, because we're having the serial number and runs scored by Sachin, Dravid and India, and moreover our NumPy is strict to only one kind of the data. If you observe and recollect, either I can go with the numerical kind of thing, or some kind of the data which is homogeneous, but we are imposing the heterogeneous kind of the aspects. Okay, so for this particular thing, just what we are doing is just we need to do something. Let me go back. So it is saying some error, as it is I cannot use this convention. I am keeping that error as it is, friends, so that you can observe what exactly that error is. Now again I am taking this cric data, cric data, same variable, and np dot load text. Again we are attempting uh, cric data. One simple thing, friends, because I want to skip the rows actually. Which row I want to skip, friends? Very first row. So what I am doing is skip rows 1. That's all. Very simple thing, especially in case of the NumPy. Okay, in pandas there is a different approach is there, so as to ignore the header. Okay, that is the most commonly used. Head equal to false or none, like those kind of the conventions we're having. But in NumPy, just to observe that if at all you want to load these kind of the data into your array kind of the notation, just to make use of this convention, skip rows equal to 1. That means the first row is going to skip. Now you see it is not okay, it is not giving any error. What you can do is cric data already there. Let us have a look on this. What it is saying, definitely it is array type 0 1 2 3 4, like that. I'm having all these kind of the data items. Okay, according to the serial number, all the data items are available. Okay, one more thing, friends, here, suppose if I want to observe the data like this, some kind of the functionalities, cric data dot shape. What is the thing? Cric data dot shape. How many rows are there, friends? Yes. How many columns are there? Yes. Okay. Correct answer. 225 by 4. Obviously, I'm having 0 to 224 from my data set. Here also you can see here. So just whatever the data items I'm having, all those particular things, 0 to 224. That means 225 rows. And I'm having serial number, Sachin row, Sachin scored, Sachin, how many runs he has scored, and Dravid, and as well as the entire India score. Okay, this is fine. But now the point is, I want to observe only the needful um, data items. That means every time I need not go and accommodate the serial number. Rather, I can have my clarity about, okay, first column, however, the record is related to Sachin, second column record is related to Rahul, second column, the data item, and third one is related to India. Now, for that particular purpose, friends, this is not new for us, but again, I am repeating. So this time we are taking one more data. So I don't want to disturb the source data. Okay, what I am doing is cric data 1. This time I am taking cric data, that is the original data. I want to have all the rows. But friends, here a typical convention like this, I want to have only 1, 2, 3. That means 0th uh, uh, whatever the 0th column I am having, that entire column I don't want. So just you can observe this 1, 2, 3. Okay. So cric data of that colon refers to the rows, and second thing refers to the columns. And I don't want to entertain that 0th column. That means that a serial number I don't want to pick up. Now you see such a simple thing, cric data 1. Now no serial number, because here you can see in the earlier implementation I can see the serial number like that. But whereas if you are talking about this thing, we are only having the serial number is not there. So just directly we could able to see the information of only the scores of Sachin, Dravid and India. Okay, so this is how you can perform usage of the required column information. Only those columns I want, so that I can pick up only those particular columns. Now we can perform, friends. Okay, so now you can easily observe that what exactly the shape of this data. Can someone help me, friends? What is the shape of the data? We have eliminated that column entirely. Rows we have not touched anything, so 225 remains same. Now you see, okay, that column is not there, na, serial number, so that it become 3 rather than. Now one more option I want actually. I want to segregate Sachin runs. Okay, just what I'm doing here is I'm taking the Greek data and I want his all scores, but I want to post only 0th column. Now don't compare with the earlier data, friend, because now we are brand new Greek data 1, and in the standpoint of this Greek data 1, we are having the 0th column as Sachin, first column as Dravid, and third column as the India score. So with respect to that particular thing, you can segregate the data. Just you can give this, and you can now you can view only the array Sachin score only. Similarly, I want to get the Rahul score. Okay, just you can manage this Greek data 1. Okay, as usual, all the rows, but this time I want only first column, which is score of Rahul Dravid. Just I can see the array. Now third thing, as usual, I want to put this particular India score, so that one can easily have the look of which are all the scores done by our team, recorded by our team. So just simple. Like that we can. So see, friends, how simple the numerical Python. Okay, just we have started our discussion with loading of the data. We are having some kind of the data which is having the records of all our two cricketers along with the India score, and there we are applying some kind of the conventions according to our requirement. Now apart from these kind of the conventions, there are certain implementations I want to show you. Like if I want to find out, okay, the mean scores, median scores of Sachin, Rahul and India. See, the requirement here is very simple. Now we are having separate data items, and all those separate data items I can get I want to get the mean, median and as well as the mean, median values of Sachin, Rahul and India. Any expectations, friends? Just to recollect the broadcasting method, and there we have applied some kind of the mean. Okay, so yeah, exactly. NP dot mean of. Okay, so now we are having that entire data, Greek data with us, and I want to get the mean of all the members. Like how we are having is all the Sachin records are there in the 0th column. All the Rahul Dravid scores are in first column. All India score is in the second column, 0, 1, 2. I don't want to get the mean of Sachin, Dravid and India. See, the simple thing. Let me open that OneNote. Hope you are seeing this OneNote. What I am expecting here is, so the data is like this, guys. Our data is like this. So the Crick info data, our Crick data one is like this. In the 0th first and second column, we are having the Sachin data, we are having the Rahul Dravid data and India data. Some values I am having, maybe Sachin 73, 75, 76 like that, is 65, 98, 70 like that I'm having, and India score maybe 233, 245, 285. Some numbers I'm taking. Now if I am applying, okay, my intention here is I want to get the mean like this, mean of all Sachin scores, mean of all Rahul Dravid scores, mean of all India scores. That means mean should be applicable to column wise, not this one friends. If I'm taking this mean, is a wrong kind of thing. There is no meaning, na? Mean of calculating mean of all these three is meaningless. Okay, but mean of Sachin I want this column, and mean of Rahul I want, and mean of India I want. Then only there is a meaningful establishment of the corresponding data. So for that particular thing, friends, what we are doing is just be with me, which is very simple, not that much complex, because NumPy is providing as you are going to have NumPy, Pandas, Matplotlib, and Seaborn, your complexity of coding is greatly reduced. Now, this time, as expected, axis must be 0, because as we have seen, our representation is like this, friends, not horizontally, but vertically. Okay, individual partitions of that particular array, so that we are taking this axis equal to 0. Now you see, the first one is, however, such in mean 39.87 in all the matches. Mean Rahul 32, and obviously we can easily say because India entire players mean that comes to 220. As we expected, we are having the median value also simple. This time also we are taking the click data, and as well as I am making use of axis equal to 0. Okay, that is what we should be very mindful. Like, suppose I want to, whether I need to get the row wise or column wise. Row wise means axis should be 1. Whereas if you want to perform some column wise, your axis is 0. Likewise, you can manage the things. And one more important thing, suppose there is some other, okay, let I want to share that thing. Find mean of Sachin, okay, grouped by 25 matches. Okay, suppose I want to get the Sachin. See, suppose he has played some. I'm having 225 match information, and I want to maintain some 25 match as one win, another 25 matches, another win, like that segregation of the matches. First 25, next 25, third 25, fourth 25, and I want to perform some kind of the computing mean. Okay, so the query is like this: find the mean of Sachin scores, okay, grouped by 25 matches. So based on that particular thing, I get the mean of Sachin score. So now, however, friends, if you remember, we separately picked up that particular Sachin scores. Now at the moment I am making use of this particular shape, as we expected it is 225. Now this 225 should be split into 25 matches each. Okay, so now there is a functionality, friends, to do that. Uh, there is a concept called reshape actually. I want to change the shape of this particular thing, and see here what happens. So 25 matches is like that. 225 has played na, so the divisible 9, and I can make use of this particular shape. Okay, so now as we expected, it is giving 9 by 25. So 25 matches is like that. I'm having 9 storages. Now what we're doing is, friends, so here 25 match bin. Uh, what we're taking is Sachin dot. Okay, so let me store separately. We are reshaping that. 25 matches into 9 different things. Now same thing. There is no differentiation, just it is splitting to these things actually. 9. Okay, this is the first, second, third, fourth. Okay, like that separately you can easily grasp that the division you can see. Okay, the division you can see in a logical way. Now I want to get the mean of these particular matches. Okay, for that one simple thing, friends, np dot mean of Sachin 25. We're having separate thing. Now x is equal to 1. Yes, you're right. Because I want to get the means of all those rows actually. Like first 25 matches mean, second 25 matches mean, third. Is a row wise, na? Row wise, obviously I should give the if it is column wise, that is a different thing. But okay, so now you can easily grasp such kind of 9 means I am getting because first to 25 matches he has 33.96, second 49.4, third 25 matches he could able to score 38.48 mean. Like that is a consistent player, na? So that we can easily he has never dropped less than 35.2. Always he's at least whatever the data set we are having in that particular data set we are having 35.2 as at least minimum mean value. Okay, mean value at least. Okay, so this is how you can prefer. Oh, one more thing is there, friend. 33. Actually, this is the minimum score he has done out of all the 9 different 25 bunch of matches. Okay. Uh, Again, so suppose if I'm having one more option because I want to specify some kind of the convention here. Let us see, friends, here. Suppose I want to get what it refers, friends. Yeah, if you are referencing this value, observe here, guys. So just if I'm making use of this convention, it is not giving such a greater than or equal to 100. So rather, what I can do is now you see, friends. Yeah, 1 minute. Yeah, just observe there. Uh, there is certain conventions, friends, where I want to get where he has to scored greater than 100 and I want to perform some kind of the activities. Okay, I want to perform some activities like where he has scored greater than 100. Now you could able to see sometimes, you know, suppose let me give the differentiation. 1 minute, guys. I want to clarify something. Sachin, greater than 100 if I'm saying, well, yeah, this is the point. There is one option, friends, actually in the Python array kind of thing. Suppose if you are attempting in any condition, if that condition is satisfied, then it is giving us true. Suppose at this point he has scored greater than 100. But if he has not scored greater than 100, always you can see this is a false. First 4 are false, but his fifth match he could able to score greater than 100. Like that, some certain places we are having true. This is one thing, friends. This is okay directly. But whereas if you combine this thing like this, such of such in greater than 100, just to see here, you want to pick up those values also. I don't want to get true false kind of the notation. I want to pick up the values also. Okay, greater than 100. Now one more point here. Let us see. Suppose I'm doing like this, friends. Np dot mean of. Now I want to place the entire aspect in this mean computing. Okay, mean computing. Now what is your expectation? Yes, you are right. We are going to find out mean of all Sachin scores when he has scored a century. Suppose he has scored century and at that time what is the mean value? Okay, so if you see his mean value is 128 because he has minimum scored as 100 mean because we are saying that he has scored greater than 100 and we can easily observe the mean. So we can refer this particular point as mean of Sachin scores when he has scored a century. Okay, so this is how Various options are there, friends. Okay, because as per the case study requirement and all, we have done some kind of the computings and all. So, but the usage I'm focusing on. Okay, so especially this particular point, if you consider, if I am directly making use of the portion of the array and if I am giving the condition, um, just it is saying true false kind of the notation. Whereas if I could embed these aspect in some kind of the list notation, okay, like these kind of the brackets, I can able to fetch the data, fetch the values actually rather than true or false boolean kind of things. Similarly, I can apply some kind of the mathematical computing related to these kind of the notations also. Okay, so this is how you can practice and get the efficiency of this numerical Python. So let me close the things by establishing the summary of the sessions, which are all the uh, takeaways of the session of NumPy. Okay, so the numerical Python uh, outcome, I am saying outcomes of the session. So basically, friends, we started with the comparing of the list versus the array, and we could able to observe the less time requirement for the arrays. This we have seen. And the second point is array. We have declared with a range, and thereafter we have seen some kind of the array. Directly, I can specify the array. In either of the case, our representation is homogeneous kind of the things. That is the second option we have seen. And the third important thing is we have worked with one dimensional array, like either a particular row or a particular column we are having. Now, once this particular thing is over, we have done with the two-dimensional arrays. We pretty know that the first thing is row, second thing is column. Okay, and but while specifying these things, we have used the double representation so as to notify we are using the two-dimensional arrays. And thereafter we have seen some kind of the usage of the random rand, which is generating some floating point data. And thereafter we have used random dot rand int, which is purely integer kind of the data. If at all you want to perform some kind of the random computings and all. And then we are having the ones and as well as the zeros. NumPy clearly provides the usage of ones and as well as the zeros, especially if you want to maintain. Next important thing, friends, applicability of some kind of the functionalities, maybe broadcasting. Okay, so within this particular broadcasting, suppose if I'm doing like this 100 into np dot zeros of some 3 by 5, all these kind of things can be broadcasted with 100. And thereafter we have seen 2s, and I can simply add these things or subtract these things like that we have seen. Is a broadcasting kind of thing. And thereafter we have seen some stats in NumPy. Okay, guys. So this particular stats helps us to find out maximum value, minimum value, and thereafter we have seen some kind of the mean, median, variance. Okay, so standard deviation, all these are the different aspects. And once this thing is over, just we have seen some kind of the case study. Uh, Vertical stack, V stack, where this particular thing is there, we have we're having some weights of the persons and height of the persons and age of the persons in different arrays. Suppose array 1, array 2 and as well as the array 3. What we have done is we have combined all these things with certain functionality, and we could able to get into the array 4, and from this you can apply whatever the values you want. There we have seen some x is equal to 0 for column axis equal to 1 for row. These kind of things we have seen. And then we started loading of the data. Okay, especially the tab separated value friends with numpy. What we have done is just we have taken some representation. So we have loaded the data, and there we have used skip rows because you remember that numpy arrays only store the homogeneous kind of the data, but this our data is having the heterogeneous, some string and all the things which won't allow. We have skipped that data. Now we got the serial number, scores of Sachin, Dravid and India. And then what we have done guys, just we have taken uh, this thing out just with the help of all the rows, and we could able to specify the representation 1 2 3. Okay, we don't want to put this particular zero again. I split that Sachin record, Sachin scores, Rahul Dravid scores and India scores. So just all the rows, just I want to pick up only 0th, and I want to pick up only first column. I want to pick up only the second column. Like that you can perform. And thereafter friends, we have seen how to perform some kind of the mean, median on top of these players along with all. And second one, we have segregated all the data into because we are having 225 total records and 9 by 25 reshaping, and then the mean value of all those matches. Third one, there is one more interesting, like if I'm having some data, if I am applying some kind of the condition, I may get true or false kind of aspects. Whereas rather if I specify like this, I am getting the exact values. And one more thing we observed, on top of this, I can easily observe a mean of the entire thing. Okay, so this is how we are maintain the convention of the numerical Python. In the next session, friends, just we are going to introduce pandas. Okay, all the best. Okay, just you can prepare, and just I am going to share the this one note along with the notion of that data set which we have used along with the Jupyter notebook also. Okay, so by today evening we are going to get, again I am going to describe the pandas also together. You will be getting those things. Okay, thank you.